Hey guys, welcome to another A-Level Maths Revision video. Today we're carrying on with some Year 2 material, and we're still early on in the text, but we're taking a look at algebraic fractions, so still part of chapter 1 here. This topic is kind of just a continuation from your GCSE maths, algebraic fractions, so it should be quite easy, but we'll look at maybe some of the questions where you're using some of your first year A-Level maths material, so logarithms and a bit of differentiation. Okay. So let's take a look at this first question here, which is essentially just a tricky GCSE question. So let's get the right pen colour. Okay, so first question here, we want to show that this expression, x squared minus 64 divided by x squared minus 36, all of that divided by 64 minus x squared divided by x squared minus 36 is equal to minus 1. Okay, so 4 marks for this. Now when you're dividing fractions like this, obviously what we want to do is just change this to a multiplication and then use the reciprocal of this fraction here. Okay, so the left-hand fraction won't change. So for now we'll just write it as it is. This right-hand fraction will change it to a times and we'll do the reciprocal, so the denominator becomes a numerator and obviously the numerator becomes the denominator. Okay. Now at this stage here, when you times into algebraic fractions like this, what we want to do is we want to start cancelling. And normally what you'd do is you'd factorise, right? We've got a lot of difference of two squares here. We've got it in this numerator, this denominator, and this denominator here, right? But if you notice, this is actually x squared minus 36, this is x squared minus 36, so straight away they will cancel. Okay, so what we've got now is x squared minus 64 divided by 64 minus x squared. Okay, so pretty similar, but we need to show that this is equal to minus 1. So what I'm going to do now is this where we factorise. So if I factorise this numerator, difference of two squares, so it's x minus 8, x plus 8. Okay, so nothing too tricky there. Denominator, so this is difference of two squares as well. This will be 8 minus x and then 8 plus x. Okay, that will give me this expression here. Now, I've got an x minus 8 in the numerator. I've got an x plus 8 in the numerator as well. Notice I've got an x plus 8 in the denominator as well, so they will cancel. So what I get left with is x minus 8 divided by 8 minus x. But this isn't quite how we need it, because we want to show this is actually equal to minus 1. But at this point here, we need to do one little extra step, and that's we need to factorise it in the denominator. So that's x minus 8 in the numerator. If we factor out a minus 1 here in the denominator, so minus 1, all we do is we change the signs here, so then we can write that as x minus 8, like so. Okay, if you expand this minus 1, that's minus x, and that's plus 8, which is what you've got there. So these are equivalent. So what I can actually now is just cancel them two. So what I'll technically get left with here is 1 over minus 1, which will just give us minus 1 there. Okay, which is exactly what we've got to show. So it's minus 1 as required. And like you can see, that is a very easy 4 marks there. If you get that in your exam, happy days. Nice easy question. So the next question, a bit trickier. The first part is pretty similar. We're just going to cancel. Part B is where we need to kind of bit of problem solving. We've got logarithms. Can we find x in terms of e? So let's have a look at part A first. So simplifying these fractions here. Well, like we've just said, when you're simplifying algebraic fractions like this, what we want to do is factorise and then start cancelling terms. So let's just factorise the numerator on the left-hand fraction first. So that's x plus 6, x minus 4. Okay, so that's my numerator there. What would be the denominator? Well, I can factor out 2x, so that's 2x, x plus 5. And then we times this by, so it's x squared minus 3x, so we factor that. That will be x times x minus 3. And again, factorise this denominator, x plus 6, x minus 3. Okay. So everything's good so far. We've factorised everything. This is the most important bit. Now, once you've got everything factorised, now we just kind of look at what's going to cancel. Well, I've got an x minus 3 here, got an x minus 3 here, so they'll cancel. There's an x plus 6 here and an x plus 6 here, so we can cancel them. Because don't forget, you've just been multiplying across here. So essentially it would just be on this side, so you can cancel it like that. We've got an x minus 4. There's no other x minus 4, so we can't do anything with that. We've got an x here, and we've got a 2x here, so we can cancel that x with that x. And we've got an x plus 5, but no other x plus 5s. So in that case, we can't do anything else. So if we just write this now as one fraction, so that's x minus 4 times 1, so x minus 4, divided by 2 times x plus 5 there. Okay, can't do anything further with it. The other thing we actually could do, sorry, would be just to expand the denominator here if we want. 2x plus 10 there. Okay, if we're simplifying it fully, I think that's what we should really be doing. So there we go. So that's part A. For part B now, well, we're given that ln of this expression here, I'm not going to bother reading it out, is equal to 2 plus ln of this expression. Now the key thing here is we're going to actually use pi A to solve part B. And why are we doing that? Well, if you notice, just change the pen colour, this is x squared plus 2x minus 24. That's exactly what we've got here in the numerator there. We've got an x squared minus 3x, for example, so we change to blue there. We've also got that there. Okay. So what I'm expecting to happen here is that we can write this as one logarithm, and then essentially what we've actually got is just the multiplication that we had in part A, which we've already cancelled. So in essence, we've done all the work for part B, near enough. We've just got to do a bit of simplifying after. Okay, so let's just try and write this as one logarithm first. So if I write this out in full first, so it's x squared plus 2x minus 24. So this is times x squared minus 3x. Now this is equal to 2 plus the logarithm here. So if I take this logarithm across, we can then start writing it as one logarithm. So that's 2x squared plus 10x times x squared plus 3x minus 18. And that's equal to 2. Okay, that 2 is still on the right hand side. And now at this stage here, just remember your rules of logarithms, I can write this as one logarithm. So this is the natural logarithm of x squared plus 2x minus 24 times x squared minus 3x. And if we're minusing this one, this would be our denominator. So this is all divided by 2x squared plus 10x times x squared plus 3x minus 18. Okay. And this is all equal to 2. Okay. So this is the key idea here, writing it as one logarithm. Now, if you notice now, what you've essentially got is just the multiplication we had in part A. Okay, so it's x squared plus 2x minus 24 times x squared minus 3x divided by 2x squared plus 10x times x squared plus 3x minus 18. So we've already done the cancelling for this part. So all I'm going to say is, seen from part A, so I'm not going to do all the cancelling again, since we've already done it. So seen from part A, this cancels down. I should say simplifies down to. So what does it give us? It gives us this expression here. So we've got the logarithm of this. Okay, this is ln x minus 4 divided by 2x plus 10. That's all equal to 2 now. And then at this stage here, all I need to do is solve for x here. So if we exponentiate both sides here, that would give me x minus 4. So if we do it over here, that's going to give me x minus 4 over 2x plus 10. So that's going to be equal to e squared. So we want to just isolate x here. So if I multiply through by this 2x plus 10, if we just start clearing everything above, so we've got enough room. Just so it's not all over the place. Can we get rid of one more line? Right, let's carry on. So it's all I'm going to do is times 2x plus 10 by e squared. So what I get here is x minus 4 is equal to e squared 2x plus 10. Okay. So if I multiply this expression here on the right hand side out, that's going to give me x minus 4 is equal to 2x e squared plus 10e squared. And if we want to solve for x here, I need to get the x's all on one side and then factor out the x. So if I take this 2x e squared onto this side and take that 4 onto this side, so it's going to look like this. So taking that across, that becomes minus. Take this across, that becomes positive. And then, like I said, at this stage here, we just factor out the x. So this is x lots of 1 minus 2e squared is equal to 10e squared plus 4. And then at this stage here, we just divide through by this to get x. So x is equal to 10e squared plus 4 divided by 1 minus 2e squared there. Okay, and there we have it. So that's 4 marks for that. Obviously, most of the work we did in part A for part B, but always try and see if you can use your initial answer here in part A to help with this. You don't want to start simplifying this all again. You've already done it. So yeah, there we go for that one. Next question here now. We've got another division one. We want to show that it can be written as this quadratic expression, and then we want to differentiate the function g of x. So this one obviously uses a bit of differentiation, and this is quite common with these algebraic fraction questions. You'll usually just have a little bit of a follow-up with another topic. So let's take a look at this one, question 5. So, like we did with the first question here, I'm going to change this to a times and flip the right-hand fraction. So, g of x can be expressed as 4x cubed minus 9x squared minus 9x divided by 32x plus 24, and then we change this to a times, and then my numerator is the denominator that we originally had, so 6x squared minus 13x minus 5. Okay, so just minus 5 there, and we divide this all by x squared minus 3x. Okay, and then like we always do, factorise, start cancelling down terms, and then just see what you end up with. So I've got this cubic expression here. So when I factorise this, because we've got an x in each part here, what I'm going to end up with is a quadratic. So if we kind of try and do this all at once, that will give me x, 4x, so give me 4x squared minus 9x minus 9. And then if we factorise this expression here, this would be x times 4x plus 3 times x minus 3. Okay, so that's that full expression there. So this here is equivalent to this. Okay, so that's x times 4x plus 3 times x minus 3. Dividing this, so this one's quite nice to factorise on the denominator. That's just going to be 8 lots of 4x plus 3. So I notice my x's are terrible, but hopefully you can still read them. Factorising this numerator here, that's going to be 3x plus 1, 2x minus 5. And then we divide this by, factorise this here, so that's going to be x times x minus 3. Okay, so now we start cancelling. 4x plus 3 here, 4x plus 3 here, so let's eliminate them. I've got an x here, I've got an x here. We eliminate them. What else can I eliminate? I've got an x minus 3 here, we've got an x minus 3 there. And then at that stage, I don't think there's anything else. Nope, so that's what we've got to end with. So it's 3x plus 1 times 2x minus 5 divided by 8 times 1. So we just write that out. Divided by 8. Now, what they want is gx written in the form ax squared plus bx plus c. So at this stage here, I'm a little bit off. Notice if you expand this numerator, you will get a quadratic. We've just got this division of 8 to deal with as well. So if we expand the numerator first, what's that going to give us? That's going to give us 6x squared. 6x squared minus 15x plus 2x minus 5. We divide it all by 8. So, minus 15x plus the 2x will actually just give us minus 13x. So, if I just get rid of that and we'll write it out again. So, that's minus 13x minus 5. Okay? And we're nearly there now. The only thing we need to do is consider dividing each term by 8. So, you could write this as 6x squared divided by 8 minus 13x divided by 8 and then minus 5 over 8. So to finish off, g of x is equal to 6x squared divided by 8. So we could write that as 3x squared over 4. Or 3 over 4 x squared. Minus 13 over 8, we can't do anything with that, so it's just what it is. And then finally we can't do anything with the last one, minus 5 over 8. Okay, so that's simply g of x there. So just carrying on with part B here. Sorry, I had a bit of a disruption. So differentiating this, nice and easy. We've got the coefficient here, times by the power. So that'd be 6 over 4. So that'd be 3 over 2 x. And then we take 1 off the power, so that'd be 1 there. So we don't need to write that. Minus 13 over 8, so times it by the power, which is 1. And then subtract 1 off the power. So that's x is 0, which is 1. So we just get left with minus 13 over 8. And then because we've just got a constant here, if you differentiate a constant, it's just 0. So this is the differential of g of x. So that's g prime of x. Okay. And then we want to find g prime of minus 2. So g prime minus 2 here. So g prime of minus 2. If we substitute minus 2 into here, we get 3 over 2 times minus 2. Minus 13 over 8. So what's this going to give us? Well, it's actually going to give us minus 3 minus 13 over 8. And if you put that into your calculator, we get minus 37 divided by 8 there. Okay, so 3 marks for that last part there. But the most important part here is making sure you can get to this g of x. The part B is just basic differentiation, so as long as you can get to this part, that's the most important thing for this question here. Okay, then we move on to the final question here, taken from review exercise 1. So this time we want to express 4x divided by x squared minus 2x minus 3 plus 1 over x squared plus x as a single fraction. So to do this, just like you would with any fraction, we want to get it over a common denominator. Now, to see what the common denominator is, we need to factorise. So 4x divided by, so we factorise this denominator first. That's going to give me x minus 3 times x plus 1, so x plus 1. Okay. So we add on 1 over x squared plus x, so we factorise that, that's nice and easy. That's x plus 1. Okay. So at this stage here, how do we get this over a common denominator? Well, this left-hand fraction here, I need to times that by an x to get it over a common denominator. And this right-hand fraction, I need to times that by x minus 3. Okay. So essentially you need to look at the other fraction and see what it's missing from that one. So 4x times x, that gives us 4x squared obviously, and then we add on 1 times x minus 3, which will just be x minus 3, and we divide this all by our common denominator here, which is x lots of x minus 3 times x plus 1. Okay, that's 4x squared, 4x times x, 4x squared, plus x, and then minus 3. Nothing else we can do with that. And we're dividing that by this expression here. x plus 1. So what we should always try and do here at the very end is see if we can cancel any more terms. So if I factorise this numerator, what would that give us? Well, that'll give us 4x minus 3 times x plus 1. The denominator is already essentially factorised, so that's x minus 3, x plus 1. So because I've got an x plus 1 in the numerator, and I've got an x plus 1 in the denominator, we can cancel them. So all I get left with is 4x minus 3 divided by x times x minus 3 there. Okay. So there we have it in its simplest form. Okay. So that brings us to the end of this video. I hope it's helped. Again, like I said, it's just continuation of your GCSE Maths Algebraic Fractions, so you shouldn't find it too tricky. But if there's anything that's unclear, please just leave a comment down below. Cheers.